Hello everyone, welcome to another exciting lesson on decoders. And today I'll be presenting on the 4 to 16 decoder, which is also an important component in the digital logic design. Right, so the 4 to 16 decoder means that we have four input lines, typically labeled from A3 to A0. That's A3, A2, A1, and A0, and 16 output lines, that's D0 through to D15. Alright, so at any moment only one output becomes high depending on the combination of the four input bits, right? So it follows a simple rule in digital design. So for n input lines, the decoder produces 2 to the power n output. So we have 4 inputs, so we are going to get 2 to the power 4, which is equal to 16 output. So it's like selecting one of 16 possibilities using just 4 binary switches. Alright, so this is the truth table for the 4 to 16 decoder, and each row shows a different combination of input bits and their corresponding active output, right? So only one output line goes high for each unique input. Now this behavior is why we call it the one hot encoding. So just one output is hot or active. Alright, so for the logic behind the output, each 16 output is defined by a unique boolean expression using AND operations on the inputs and their inverses. So for example, for D0, we are going to take the zeros as our complemented form. We are going to take the ones as our true form. So for D0, we are going to have A3 complement, A2 complement, A1 complement, and A0 complement. For D1, we are going to have A3 complement, A2 complement, A1 complement, and A0. For D2, we have A3 complement, A2 complement, A1, and A0 complement, and so on and so forth until we get to D15, where we have A3, A2, A1, and A0. So every output requires a specific combination of the four inputs. Okay, and these expressions are implemented using the basic logic kit, which we'll be doing in a short moment. Alright, so now let's look at how to design this decoder using basic gate. So you are going to need 4 NOT gates to generate the complement of A3, A2, A1, and A0. You are going to need 16 AND gates, each with 4 inputs, right? So each AND gate is connected to a unique combination of the inputs and their complement. Now only one AND gate will be activated for any given input, ensuring that only one output is high at a time. Now this guarantees the mutual exclusivity among the outputs, right? So without wasting much time, let's start building our 4 to 16 decoder. Alright, so we are going to need 16 AND gates. So let's quickly fetch our AND gates and start building our 16 AND gates. So this is our first one, and we are going to need a 4 input decoder, a 4 input decoder, 4 input AND gate. We are going to need a 4 input AND gate, right? Right, so we make it 4 input. We are going to have 16 of them, so that's our first one. Second one, our third one, then we have the fourth one, then we have the fifth one, then we have the sixth one, we have the seventh one, we have the eighth one, we have the ninth one, we have the 10th one, we have the 11th one, we have the 12th one, we have the 13th one, have the 14th one, we have the 15th one, and finally we have the 16th one. Alright, so since we are going to have our output, let's quickly generate our 16 output. So we're going to have our first output here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then we have our 16. Alright, so let's connect our output. We have our output. We have another one here. Alright, so I'll just put in the output for all of them. Alright, so with our output ready, let's go ahead and construct our input using our truth table here. Right, so we're going to have 4 inputs together with their NOT gates. So 1, 2, 3, and then 4. Right, then right, and then their NOT gates. You are going to need 4 NOT gates. So that's our first one. Our second one. Our third one. And then the last one. Alright, so using our truth table, let's start building our AND gate. Right, so for D0, we are going to have 0 0 0 0. So using the 0 as our complemented form and 1 as our true form, we are going to have 1 2 3, then finally 4. So this is for D0. Right, so we are going to do the same for the rest of the AND gates. So for the second one, we have 0 0 0 1. So we have 0 0 0, and the last one is the 1. Right, so that's for D1. Right, so moving on to D2, we're going to have 0 0 1 0. So for D2, we have 0 0 1 0. Right, for D3, we have 0 0 1 1. So um, 0 0 1 1. Okay, so for D4, we have 0 1 0 0. So for D4, we have 0 1 0 0. So for D5, we have 0 1 0 1. So for D5, we have 0 1 0 1. So for D6, we have 0 1 1 0. So for D6, we have 0 1 1 0. For D7, we have 0 1 1 1. So for D7, we have 0 1 1 1. Alright, so for D8, we have 1 0 0 0. So for D8, we have 1 0 0 0. Right, so for D9, we have 1 0 0 1. So for D9, we have 1 0 0 1. Alright, so uh, for D9 we said we have 1001, right? So we are moving on to D10 where we have 1010. So for D10 we have 1 0 1 0 1 0 1 0. Alright, so for D11 we have 1011. So for D11 we have 1 0 1 1. Then for D12 we have 1100. So for D12 we have 1 1 0 0. For D13 we have 1101. So for D13 we have 1 1 0 1. For D14 we have 1110. For D14 we have 1110. For D14 we have 1 1 1 0. And finally for D15 we have 1 1 1 and finally 1. Alright, so our 16 to 1 multiplexer is ready. So we can actually test for it. So this is D0, this is D1. This is D2, this is D3, this is D4, this is D5, this is D6, this is D7, this is D8, this is D9, this is D10, this is D11, this is D12, this is D13, this is D14, and finally we have our D15 decoder. Alright, So as we can see from the truth table, for D0 we have for D0 it has to be 0000. So we can see that D0 is active. For D1 it has to be 0001. So let's test for 0001. Let's see how it will go. So 0001, we can see that D1 is now active. Okay, so let's test for D2, that's 0010. So 0010, so we can see that D2 is active. And then let's test for D3, that's 0011. So 0011, and we can see that D3 is active. And then finally we can test for 1111, so that will make D15 active. Alright, so this is how the 16 to 4 to 16 decoder works. Okay, so it is heavily used in digital systems for address decoding, device selection, and instruction decoding. Alright, so thank you for your attention, and I'll see you next time. Alright, thank you.